right, in this lesson, we're going to be evaluating algebraic expressions. Let's define two things real quick. A variable is just going to be a symbol. It's often a letter like X, Y, or Z. It stands for a different number. And then an algebraic expression is a combination of numbers, variables, and operation symbols like plus, minus, multiply, divide in here, and grouping symbols like parentheses or fraction bars. And a word of caution, 3m squared, for instance, means 3 times m squared, not 3m times 3m. So unless parentheses are used, the exponent refers only to that variable just before it. So we're going to use parentheses to write 3m times 3m. It would be 3m, and we sometimes say it quantity squared, that the whole thing is squared. So really be careful with that going forward. Okay, so to evaluate an expression just means to find the value after substituting the numbers for the variables. And be sure to remember the order of operations that we had in an earlier lesson. And so this example here says evaluate 9x plus 2 for x equals 4. So wherever I see an x, I'm going to put a 4 because x equals 4 now. So I'll have 9 times x, which is 4, plus 2. Now we still need to use order of operations. So what comes first here? Good. We have 9 times 4 is 36 plus 2. And then 36 plus 2 is 38. All right, this next example. Evaluate 5 plus 2x for x equals negative 2. So now we're going to substitute a negative 2 in for wherever we see an x. And so we'll have 5 plus 2 times negative 2. And I highly recommend every time you write a problem in math, every time you see a problem in math, you go ahead and write it down. Write the problem down and then write the first step down, and that'll get you started. And so here we're going to multiply before we add. So we'll say 2 times negative 2 is negative 4. So 5 minus 4, or we can say plus a negative, is 1. We'll do a few more of these. So evaluate 20 minus 2x squared for x equals negative 3. So our process is the same. Everybody's first step should be the same. You're going to write the problem down. So wherever we see an x, we're going to substitute a negative 3. So we'll say 20 minus 2 times negative 3 squared. So everybody should have that step down. Now we're going to use our order of operations. And what comes first? Good, exponents. So I'm going to exponentiate this negative 3. So negative 3 squared is 9. So I'm going to write this down. 20 minus 2 times 9. Now what comes next? Good, I'm going to multiply next. So I'm going to say 20 minus 18. And now we can go and subtract and get 2. Okay, this next example. Evaluate 3x squared plus 2x minus x for x equals negative 1. Well, now we have x showing up in two different places. So we're going to have an x here and here. And so we're going to plug in the negative 1 wherever we see the x. And so everybody should have this on their paper. So 3 times negative 1 squared plus 2 times negative 1 minus 4. And now we use order of operations to solve this. So we're going to have negative 1 squared is 1. So 3 times 1 is 3. 2 times negative 1 is negative 2. And then minus 4. Now, many students find it easier, and I do, to go ahead and change subtractions to plus a negative, particularly when we have different signs. You know, if it's something like 8 minus 2, I'm not going to do that. But when I start having like negative 8 minus 2, I will. And I highly recommend that you do too. And so here we can say 3 plus negative 2 is 1. And then 1 plus negative 4 is negative 3. All right, let's look at this next example. 3x minus 1 all over 3 minus 2x for x equals 5. So again, wherever I see an x, I'm going to substitute a 5. So 3 times 5 minus 1 all over 3 minus 2 times 5. Now recall from earlier lesson, when we have the fraction bar, we're going to do everything in the numerator and everything in the denominator. So let's focus on the numerator first. So I have an order of operations to do first. I'm going to multiply. So 3 times 5 is 15, minus 1. Do the same thing in the denominator. What's going to come first? Not 3 minus 2, but I have multiplication. So 2 times 5 is 10. So 3 minus 10. And now I just do the subtraction. 15 minus 1 is 14. 3 minus 10 is negative 7. And now I can divide that. 14 divided by negative 7 is negative 2. Okay, evaluate 5a plus 4b for a equals 2 and b equals 3. So the one slight difference here is that we have two unknowns, two variables, a and b, and they're both given values. And so we can still go ahead and do this fairly easily. A is 2, so wherever I see an a, I'm going to put a 2. So 5 times 2 plus 4 times b, in this case b is 3. So 5 times 2 is 10, plus 4 times 3 is 12, and I get 22. Okay, this next example, evaluate 5 times the quantity a plus b minus 1 all over c for a equals 2, b equals 3, and c equals 6. All right, we're going to substitute for my variables. So 5 times a plus b, we'll say 2 plus 3 minus 1 all over c, which is 6. I highly recommend developing the practice of writing down what you're doing and not doing so much in your head. Now, there are some times where you're going to want to do stuff in the head. It just makes things a little bit easier. But really make sure you're writing down your work. And so now we can do what's in parentheses. Again, we have order of operations. So we're going to say 5 times 5 minus 1 all over 6. 5 times 5 is 25. Minus 1 over 6. 25 minus 1 is 24. Over 6 is 4.